Okay, hello everyone. Welcome to this CertX webinar where we are going to talk about cybersecurity applied to the automotive industry and more specifically about a recent standardized framework called the ISO 21434. So, just to quickly introduce myself. So, my name is Gillian Marty and I'm responsible for cybersecurity activities at CertX. I have more than 5 years of experience in industrial cybersecurity and functional safety fields across several types of projects, going from compliance assessment to fundamental researches about future of cybersecurity. I'm also actively participating to several groups working on standardization of cybersecurity across industries, from generic approaches such as the one applied for machinery and automation, where the IEC 62443 standard is applied, to more industry-specific one, such as the ISO 21434, which is the main topic of today's webinar. So before going to the technical content of this presentation, maybe some clarification about this course. So the content of today is based on the final draft version of the ISO 21434 that were published current February this year. Therefore, any content that you may get here may potentially change in the next few weeks or months, since this document is not officially published in its final version. However, as I said, we are currently in the final draft version, therefore there should not be major modification applied until the official publication. Another point is that at the end of this 1-hour webinar, you will not become an automotive cyber engineer, unfortunately, but if you're interested, you can contact me later on, because we are also providing certification courses and trainings about that topic, and we provide that online or on site, so feel free to contact me after that. Logistically now, you don't need to take any photos or screenshots about the material here, because we are going to upload the video of this webinar later on our website, and you will be able to freely access it without any registration. And I will also send you the material of this presentation directly to your email address that you put in the registration form. We are going to end this webinar with a Q&A session. Therefore, thanks to keep your questions open until the end of this presentation, and I will try to address them afterwards. And last but not least, I would kindly ask you to keep your mic muted to make easier for others to hear without any other noise or echoes. So, some quick introduction about our company called CertX. We are a certification body in the cybersecurity and functional safety domains, and our biggest mission is to identify the right applicable requirements for several types of systems used across several application fields, and evaluate them to validate that a target is meeting the state of the art for cybersecurity or functional safety. And this state of the art is mainly represented by international standard, depending on the industries. We are following a similar scheme from an industry to another, and here you can have an overview about the domain on which we are working. It goes from machinery, robotics, automation, of course, automotive, yes, drones, railways, and some others. And you have here a list of technical standards that represent our core competences. So who we are? As I said, we are a certification body, and we are accredited by the Swiss accreditation body. That means that the certification and reports that we are delivering are recognized worldwide. We are based in Switzerland, and in order to be able to support the innovative solutions, we are actively participating to the standardization and normalization of new topics, such as the cybersecurity in specific application fields, and cybersecurity in automotive is definitely one of them. So the services that we are proposing are about training and certification of engineers, the assessments of products and related processes. It means the technical evaluation of a target from an independent perspective. And beyond of the assessment, we can also certify the products, processes, and management systems to validate that a company has correctly implemented the cybersecurity and functional safety requirements for all the phases of a development project. So it goes from the development, of course, but also production, operation, maintenance, and decommissioning parts. Here, a quick overview of our certification training scheme. So we have 3 levels going from the basic understanding of the standard, what we call the red belt level, to an advanced and experienced level called the master belt. And of course, you may take an exam at the end to validate that you get the right knowledge about the standard and you can implement it in your company. Here's about to give you an overview about our trainings that we are currently offering. So for automotive, we are proposing several topics from software development management with ASPICE to ISO 26262 for functional safety and SOTIF and so on. And of course, our certification training about the ISO 21434 for automotive cybersecurity. You can see it right here. Here you have an overview of our certifiable trainings, but we are also proposing tailored trainings to develop cybersecurity and functional safety culture in companies. Therefore, once again, feel free to contact us directly if you could be interested by some of them. Here's some words about our services on product level. So we always start with an initial assessment, what we call the gap analysis, to identify how far is a target from being compliant to the applicable cybersecurity or functional safety requirements. But we can go beyond of that and go to the full certification project, which implies the following approach, with an initial identification of applicable requirements, which define the certification scope, then go through the technical evaluation, through the assessment and the validation of the implementation of processes through the on-site audit. Finally, if the entire set of requirements has been fulfilled by the customer, of course, we deliver formal certificates which has an accreditation behind it. So basically that's it for the introduction of CertX. I hope it was not too long. So now let's start with our webinar itself. So we could have discussed for hours about cyber incident in the automotive world, about the Jeep hack in 2015 by Miller and Valasek, or even about the results of cybersecurity audit carried out every year by Tesla, Tencent, and some others, but they are not the purpose of this webinar. Today we will focus on why cybersecurity is a critical and daily issue in automotive and how to minimize these new cyber risks. So maybe let's start with some aspects that highlight the need of cybersecurity in the automotive industry. So in the beginning, a car, or let's use the term machine, could be described as a device having a unique purpose that augments or replaces human or animal effort for the accomplishment of a physical task. It was quite simple, but nowadays we do not talk about such simplicity anymore. A car cannot be described as a cyber-physical systems, which is a mechanism that is controlled or monitored by computer-based algorithms, tightly integrated with the internet and its users. So these aspects are key factors for the development of cyber-secure systems. So there are lots of factors, the complexity of automotive systems and architecture that are fastly growing, as well as its number of interfaces, including internet. And on the evil side is evolving as well, and there is a huge number of potential hackers which demonstrate every day the weaknesses of automotive systems. And these are the reason why only following some best development practices is not enough to provide a system which is considered as secure. Here, a complete framework integrating cybersecurity principles is therefore required. So the purpose is targeted by the development of this ISO 21434 is definitely the development of this kind of framework. So the next question that could be raised from that is, aren't there already other standards that can be used or reused in the automotive context? And the answer is not really. Because as a first element, the functional safety standard, which is already applied in the automotive industry, the ISO 26262, is a tailored approach to address automotive risks, yes, but unfortunately does not provide adequate tools and methods for cybersecurity risks. And as a second element, the other cybersecurity standards do not address the same challenges as the one that the automotive industry is facing. As a first point, if we take the safety, if your phone is hacked, for instance, somebody is not going to die. Well, with a vehicle, if something goes wrong, somebody could die or have severe injuries at least. Long life cycle as a second point. You will replace your phone every 2 years maybe, while vehicle average life around 12, maybe 13 years. So it's a long life cycle that we have to deal with when we know that hackers will always get access to last exploits and tools. The use of embedded controllers as well, which are the most of the time resource limited and make systems more complicated physically also. And all other items that go along with it. So there are so many justifications for the development of a specific standard as the ISO 21434. So what is the benefits for this automotive cybersecurity standard? So one of the main goals is here to define a common terminology that we will use throughout the supply chain. So if we are using the same terms, if we are evaluating risks the same way, that will be beneficial for everyone. It will also help make sure that the industry has consensus on key issues and help us to set minimum standard for cybersecurity, which is really, really important. It will also show the regulators that we are working together and act as reference for them to minimize contradictions. And last but not least, it's important that the people understand that the automotive industry are taking cybersecurity seriously. And in the second step, it will also help a certain social acceptance about smart automated vehicles. So now let's focus on the standard itself and how the automotive organizations can handle it. So maybe as a first shot, a brief overview of its key principles. So first of all, it's applied to road vehicles. Okay, so we are not talking anything off-road. And the goal is to provide reasonably secure vehicles and systems. That's the idea. As we understand, we cannot guarantee security, but we can have a level of confidence in the level of security. and it helps show that we are doing due diligence, what we should be doing in cybersecurity, definitely. The focus is on cybersecurity engineering, the overall process engineering, and it's based on the current state of the art for cybersecurity engineering. So that being said, it's going to be focused on a risk-oriented approach, that all of the design decisions are focused on level of risk, and that will indicate what type of mitigations are needed. So it's a risk-focused standard, and it's helped to help people understand what prioritization is needed in various design issue. So you look at the risk factors that are associated with potential acts and incidents, and then based on that, you can logically derive cybersecurity requirements. Another point is that it's useful for managing activities related to cybersecurity. It's important to understand for all phases of the vehicle lifecycle, everything from the design all the way to decommissioning, including, of course, development, production, operation, and so on. Well, what's it applicable to? This is an important point. So it's applicable to the road vehicles, the systems in that vehicle, and its component and software parts, and also the connection to the outside world. Okay? So for instance, to an external computer or whatever device network. Well, no, what is out of scope? Well, there is some things that are out of scope, of course. So, for example, it will not prescribe any specific cybersecurity technologies or solutions, because if we do, we say you should use these systems and these solutions, and well, 2 months later it's obsolete. So we want to make sure that we focus on the right things. It's not to give you remediation methods, but only techniques to identify where they are needed. It's not going to include requirements related to telecommunication systems or communications to back office. So it's not going into the technical mitigations, but it's going to be a process-oriented standard, what you should be doing from a design perspective. As example of out-of-scope application, we could mention chargers for electric vehicles, autonomous vehicles, which would require additional activities and specific activities to tackle automated function and specifically learning processes. So the purpose of course, again, the purpose is to make sure we have a structured process for managing cybersecurity. Make sure we design it upfront and that it's done throughout the entire design cycle, and helps us have a structured process to make sure we have enough outcomes to reduce the likelihood of a successful attack. And it's that structure and framework which will allow you to handle constantly evolving threats landscape. Then consistency across the automotive industry is also very important, and to basically promote and make sure we have a complete process in regard to decision making. So let's finally jump on the standard structure. So for those who already been involved in safety related activities, I think that it should speak to you, because the structure is totally aligned with the ISO 26262, which is the functional safety standard applied in the automotive industry since around 2012. So this property has been taken as a primary requirement during the development of this standard to facilitate its integration in organizations' management system. Of course, some new processes are defined, but their implementation coupled with a functional safety framework should not be too difficult and should not require lots of additional resources. So, like any other standards, some parts are just informative with the terminologies and descriptions, and some others describe formal requirements to be fulfilled by automotive organizations if a compliance is targeted. Here I segmented the entire set of requirements in 5 types. So first we have a set of requirements concerning the general cybersecurity management, which is included in the part 5 and part 15. Then we have a second set of management related requirements, which is here considered as project specific in part 6. I will come back to that later. Then in a third and fourth type of requirements regarding respectively continuous cybersecurity activities and risk assessments in parts 7 and 8. And finally, the biggest set of requirements, which describes REX per life cycle phases and which are defined in part 9 to 14. So now I will go through each of these parts without digging too much, but just to give you an idea about the topics that are addressed by each of them. So let's begin with the general cybersecurity management part. So clause 5 is basically the general overall cybersecurity management process over the entire life cycle, sort of again of a high level overview from a cybersecurity management perspective. We are going to find similar requirements as the ones specified in the ISO 26262. So we are talking about governance, cybersecurity culture to be developed by organizations, risk management, audits on organization level here, tool management, and so on. Once again, I will not dig too deep in every topic. Feel free to ask questions at the end during the Q&A session, and or even contact me directly if you prefer. Then you get into more project-dependent management activities with the part 6. So here the clause addresses additional management activities to be performed in some specific contexts, such as for component developed for out-of-context purposes, how to handle off-the-shelf components, how to deal with the reuse of pre-developed modules, and so on. So the idea here is to provide inputs for the tailoring of management activities in regards of every specific situation and context. The next part is, in my opinion, one of the most important one for handling the continuously evolving threat landscape, because it describes the activities to be performed all along the lifetime of a target to ensure that our current cybersecurity posture always fits with the current threats. So here the clause address the management related requirements for the cybersecurity monitoring, how to manage the assessment of cybersecurity events, how to manage when one of these events is considered as a cybersecurity incident based on its risk level, and finally how to manage tangible cybersecurity vulnerabilities. So in terms of real processes to be implemented for these topics, I will come back to that later when I'm going to focus on the part 13, covering maintenance processes, incident response, and some others. Now, last part before addressing real development-related activities. So here the part 8 describes risk assessment techniques and methods that are required to be performed to design your target adequately. As a reminder, this standard is based on a risk-oriented approach. Therefore, every cybersecurity-related processes and features should be implemented to cover tangible risks that have been identified through such risk assessment activities. So the idea here is to follow a pragmatic approach for cybersecurity, because without any risk references, you will indefinitely engage resources for that and never reach any cybersecurity goal. Well, Last parts that we will quickly address today are about concept, product development, and post-development phases. So here I'm going to give you a brief overview of such parts, but some small webinar will come probably during the summer, focused on some of those clauses to give you more information about the activities and methods that are required by each of them. But in a nutshell, and as I already mentioned before, the phases here described are completely aligned with the ISO 26262 framework. Therefore, process defined for the concept phase, for instance, follow the same approach as the one proposed by the functional safety standard. With the definition of items as an initial step, then the identification of cybersecurity goal on a high level, mainly based on some risk assessment methods, such as the famous threat analysis and risk assessment, the so-called TARA. And then based on those goals, cybersecurity requirements should be derived and included in a so-called cybersecurity concept. So here the idea is to get an overall relationship matrix with threat scenarios, potential causes, quantified risks, and any other information that are relevant to link high-level cybersecurity goals to cybersecurity requirements. And those requirements materialized in the cybersecurity concept should be used as the main inputs for subsequent product development phases, which follow basically a standard V-cycle approach. So of course, we are going to find some specific methods and techniques for development phases too. For instance, for testing, verification and validation steps, code reviews focused on input validations, penetration tests on different levels, technical audits, some additional activities to be integrated in the development lifecycle to have tools to handle cybersecurity issues. And then, as a last set of activities, we are going to find post-development phases from 12 to 14 to cover cybersecurity issues across the production, operation, maintenance, and decommissioning phases. So for production first, this standard does not define any other specific requirements than the preparation of a production control plan. So it's quite light. So here a good practice could be to implement a secure manufacturing production process according to other standards, such as the IEC 62443, which provides a generic approach to handle cybersecurity in industrial context, and which could add a valuable layer of security on your production process, definitely. For operation and maintenance now, as I introduced before, the clause 13 addresses mainly how to deal with cybersecurity events that raise from monitoring activities. So here we are talking about incident response and vulnerability handling processes, mainly. So how to find a solution to a cybersecurity issues and patch it without introducing other security weaknesses. That is also why the management of updates is already addressed here. What is the process to develop a patch and ensure that the targeted vulnerability is mitigated by this patch, and also how to securely deploy the patch. It's a main question. And yeah, these kind of questions are addressed by the requirements of this clause 13. And once again, last but not least, decommissioning activities are covered by the part 14. So here the cybersecurity implication of decommissioning should be considered, but the process of it cannot be handled by organization, because sometimes, or even most of the times, it can occur without the organization knowledge, and in such a way that decommissioning procedures cannot be supervised. So you have to take care and to consider cybersecurity risks during decommissioning, but you will probably not be able to supervise it. Well, um, basically that's it for the content of this webinar. As a conclusion and in a nutshell, in automotive, like in any other industry, the cybersecurity should be considered as an ongoing process rather than an ultimate goal to reach. So that is one of the main difference with functional safety, where except the reliability aspects, which will definitely evolve with the time, new risks should not appear during the lifetime of a product if no modification is made on it or its environment. While in cybersecurity, of course, there are zero-day attacks every day, and staying aware of that is a huge requirement here. Well, as I mentioned, also the ISO 21434 defines a risk-based processes framework to handle cybersecurity in the automotive industry, and that is totally new. And it will probably create a lot of changes in organization management systems when its official publication will come. And it's planned probably for December this year. And once again, other webinars about that topic and other industrial cybersecurity one will come soon. So feel free to follow our website and LinkedIn pages to be informed about those upcoming events. Thanks a lot for your attention. I hope that this presentation has been interesting for you. It was really an introduction here, and we will dig a bit more about some activities, some cybersecurity activities specific to automotive industry, probably through other webinars. So feel free to follow our website and LinkedIn pages to be informed about that. Thanks a lot for your attention. I hope this covers your needs. And as explained at the beginning, we are going to have a small Q&A session now. So feel free to write your questions in the chat, and I will try to answer them as clearly as possible. And I remember you that I will send you the material of this presentation by email. And if your time limit won't allow me to address every questions, please do not hesitate to contact me directly. And you have my contact information at the beginning of this presentation too. So I would be happy to answer to your questions or requests by email too. So, is there any questions? So what are the most recommended tools to address cybersecurity? So cybersecurity tools are a quite complicated world because there are lots of cybersecurity tools to perform penetration tests. And yeah, these tools are mainly targeting IT infrastructure. And they are currently transferred to the OT world to also cover new challenges in automotive, for instance. And you will find some tools to manage cybersecurity requirements. For instance, we can mention ANSYS, for instance, but it will allow you to manage cybersecurity requirements and maybe some models, but it will not allow you to securely develop a product or to perform some penetration tests or security audits. It's really an ongoing process now. The tools will come because it's quite new, but yeah. Other questions? This standard is applicable for which type of organizations in automotive supply chain? So basically, the requirements defined in this standard could meet the needs from any stakeholders in the automotive industry. So basically, if you are providers of an ECU, you will find some requirements to manage the cybersecurity of your product. Of course, if you are interested in your security as an infrastructure owner, if you developed some vehicle, for instance, your infrastructure could be certified according to other norms, such as the ISO 27K series for the management of cybersecurity of IT infrastructure, or even the IEC 62443 for the industrial part of your infrastructure. But here, the requirements in the ISO 21434 is really targeting the developers of products to be implemented in vehicles. So it could be a software parts or an hardware parts, or even an industrial switch to be deployed on a vehicle, but only systems that are deployed on a vehicle itself. So maybe another questions. So how about ISO 21434 cybersecurity standard? Will it be applicable to all types of road vehicles, including special purpose vehicles? So the answer here is definitely yes. It's applicable for special purpose vehicles, but as I mentioned before, also automated vehicles is another topic, because there are lots of new trends around it, and for instance, the learning processes, artificial intelligence, and stuff like that is quite difficult to tackle with a standard like that. So we could mainly add some new approach like the one proposed by SOTIF to address these risks. But at the moment here, it's just for typical vehicles which work in a normal way. So what is the best way to start the implementation of this framework? So the best way to start would be probably to initiate kind of gap analysis between your current project development activities that you already performed. If you already implemented the functional safety standard, for instance, it could be interesting for you to initiate a gap analysis here, just to evaluate and to identify where the main activities needs to be tailored, because the risk assessment is also required for functional safety, of course, and there are just some additional aspects to take into account to integrate cybersecurity risks in such in such functional safety risk assessment. So the two frameworks are definitely complementary, but the approaches between them are totally similar. So you can quite easily integrate them together. For teleoperation, those server or control centers which are out of vehicles are also subjected to these standards. So for teleoperation, it's a bit different, because here you will have, as you said, a server or control center in a remote way, and the cybersecurity of this infrastructure, remote infrastructure, should meet the requirements of standards such as the ISO 27K, because it's normal IT infrastructure, but you have to build a link between the cybersecurity of your remote center and your vehicle. So the channel between the communication channel between your vehicle and your infrastructure is covered by the ISO 21434. So you have to provide, of course, authentications, confidentiality, integrity, and stuff like that. But you will not be able to apply the ISO 21434 on the remote infrastructure itself. Of course, you can implement the cybersecurity assessment, the risk assessment approach for that also. It's a good approach, but some other requirements will be required for your remote infrastructure. So when final version of this standard is likely to be published? So at the moment, the date that is planned is in December this year, 2020. So let's see how it goes. As I said, normally we should not have major modifications between the draft version and the final ones. But now we just review some feedbacks about that. But it's more rewarding stuff than really modify the standard itself and then the requirements. So it's only applicable to L1 to L3 at the moment. So about the level of autonomy of vehicles, so it's set only applicable to level 1 to level 3 at the moment, and level 4 and 5 are too complex for it. Basically, yes, you can definitely implement it, but the standard will probably evolve in the future to fit with the requirements of automated and sport vehicles. Because as I said, you cannot, these standards does not provide adequate tools and methods to evaluate risks that you don't know. For instance, if we took the example of quantic computing, for instance, you can't at the moment implement asymmetric cryptography to deploy confidentiality and authentication and stuff like that with PKI and certificates. But if in 2 years there are quantic computer everywhere, your algorithms are basically broken. So these changes in paradigms require to be a bit conservative regarding the standard application. So basically, yeah, the automated vehicles are not really the main target of this standard. And yes, SOTIF can definitely give you some good tools to tackle this kind of risks that you don't really know at the moment. So now the state of the art for the management of automated vehicles, if I can say like that, is the implementation of the ISO 26262, of course, and the integration of SOTIF tools to integrate risks that you don't know in the risk assessment, and also the ISO 21434 in the approach to take into account cyber risks. But probably new standards will come to tackle that. You can now find some best practices or guidelines for the development of secure automated vehicles, but it's not considered as standardized. It's just good practices, guidelines, and stuff like that. Okay, so it seems that we don't have any other questions. Feel free to ask. We have a few more minutes. Okay, so it seems that we don't have any other questions. So once again, thanks so much for your participation, and feel free to contact me directly for any questions about automotive or more generally industrial cybersecurity. And if you have any other questions about other topics that we addressed at CertX, please do not hesitate to contact us directly through our website, and we will take care that the relevant person will recontact you as soon as possible. So thanks again, and we continue. Maybe last questions. Can we take an approach? We take care of safety first and then include cyber. So last questions. Can we take an approach? We take care of safety first and then include cybersecurity later. The answer is no, because without you cannot provide a safe systems without cybersecurity. Because by implementing a functional safety standard, of course, you can evaluate the risks intrinsic from your system if a failure of your functions happens. But if an attacker can gain access to your system, he can change the behavior of your system, and your system will not detect as a failure. So with this potential alteration of system behavior, you're forced to implement cybersecurity to provide at the end functional safety. So it should be a prerequisite here. Basically, if there are interfaces on a systems, yes, a non-secure system is also a non-safe system. Yeah, definitely. But if you do not have any interfaces, which is not really realistic, but yeah, if you do not have any interfaces, yeah, here in that context, you can only deal with functional safety, but you will always have interfaces, physical one at least. Okay, so thank you for your questions. thanks again for your participation, and I think that we can end it right now. So thanks again, and I hope to see you soon. Bye.